Hello, family. Welcome to another session of Maths Fanatics 24/7. In this video, we're going to be looking at probability, more specifically, all the important formulas and terminology that you need to have in your vocabulary of probability for you to do well in this section. Trust me, ladies and gentlemen, this is the most important video for probability, because if you don't know these formulas, you are not going to do well in this section. So please focus very much on this video first before you can go to the next videos. Okay, so we're going to start with mutually exclusive events. So when you hear the word mutually exclusive, mutually exclusive, it means that these events cannot occur at the same time. Does it make sense? For example, if I were to draw the Venn diagram for mutually exclusive event, this will be the circle for event A. This will be the circle for event B. There won't be an intersection, right? Or if there's an intersection, let's do this. A and then B there. The probability here would be 0. Right. So these two Venn diagrams represent mutually exclusive event. The probability of A and B and B must be equals to 0 if the events are mutually exclusive. So if the question asks you to prove that two events are mutually exclusive or not, you are always going to use probability of A and B. If it's 0, they are mutually exclusive. If it's not 0, they are not mutually exclusive. And sometimes they'll tell you that the given events are mutually exclusive. Basically, they would have given you this identity, that probability of A and B are going to be 0. Perfect. And then that's it about mutually exclusive. Okay. So now let's go to the addition rule, right? The addition rule is basically a rule that applies to all type of probabilities between two events A and B. So this will always hold, regardless of whether events are dependent, independent, mutually exclusive, complementary, and all that. This formula is the most important formula, right? You have to know it off by heart. But sometimes I think it's given on the formula sheet, but I always advise you to know all the formulas off by heart, right? Awesome. So it says probability of A or B. Actually, let's draw a Venn diagram here too, so that it makes more sense. So I have event A here. I have event B here. Right, okay, let's say A. I'll call that small a, small b, small c. Sure. So probability of A or B, right, is the probability of A, which is A plus B, right? And then the probability plus the probability of B. Probability of B, it's B plus C. You see the circle of B is the green, is B plus C, plus B plus C. And then we have to minus the probability of A and B. Probability of A and B is where the two circles meet, which is this part here, right? Why do we have to minus it? Because this number has been counted twice, here and there. Do we get it? So minus B. So it's basically A. So this B will cancel with that one. Then I'm left with A plus B plus C, right? So in simple terms, probability of A or B is basically all the events in the circles of A and B added together without repeating any event. So if the question asks me for probability of A and B or B, I'm just going to add this plus that plus that. That makes sense. But the formula is also important. You should know both ways of how to do the calculation. And that's it about the addition rule. It's just a rule that is used to add two events that are being compared, right? Perfect. And then now we're going to do Okay, let's check this one before we move on. The addition rule for two mutually exclusive events. Ne? Remember, mutually exclusive events, we said PA and B is equals to 0, right? So obviously the addition rule will still have this part, and that part. This part will disappear because it's equals to 0. So that's why here you have PA or B, which is that part, equals to PA, which is this part, plus PB, which is that part. Because it's mutually exclusive, that minus PA and B is going to disappear because it's equals to 0 here. Do you see it? Because of mutually exclusive. Perfect. And then now let's check the third part. Complementary rule. So let me edit here actually, and I'll show you what that means. So probability of an event plus probability of not an event must always add to 1 if they are complements. Right. So probability of A plus probability of not A, it's always going to be 1. Always. For example, if the chance of raining is 35%, the chance of not raining is going to be 65%. Do you get it? If the chance of winning a game is 30%, the chance of losing it will be 70. When you add them, you're always going to get 100%, which is 1. Does make sense? Perfect. So for one event, it's always true that probability of A plus probability of not A is equals to 1. Ne? Perfect. And then there's something that they didn't put here, which is, let me just put it here, an exhaustive events. Ne? If two events are exhaustive, probability of A plus probability of B must be 1 if they are exhaustive. Ne? If two events are exhaustive means use the whole sample space. Remember, the sample space is 100%, which is 1. So if two events are exhaustive, when we add their probabilities, we're going to get 1. So if the question asks you to prove if events are exhaustive or not, you have to show that probability of event A and event B, when added together, they are going to give us 1. Perfect. And then now let's come here. Ne? Independent events, right? Last one. Independent events are two events where knowing the outcome of one event does not affect the probability of the other event. A good example here would be giving birth. Like if the first child was a boy, right? It is not going to influence whether the second chance or the third child is going to be a boy or a girl, right? So the previous gender does not necessarily going to influence the what? The coming gender, like the gender of the newborn. Does make sense? Perfect. And then if two events are independent, this formula is always going to be true. Ne? This formula is always going to be true. Probability of A and B will be the same as probability of A multiplied by probability of B. So if the question asks you to prove if events are independent, you're going to take probability of A and B, get the answer, and then take probability of A and multiply by probability of B and get the answer. If the two answers are the same, they are independent. If they are not the same, they are not independent. And then if a question tells you that the two events given are independent, they are actually saying you are allowed to use this formula. Does make sense? Yeah, ladies and gents, that's it about formulas for probability. Ne? You're really going to need to know this off by heart for you to do really well in this section. If you found this really helpful and think it can be helpful to a brother or sister or family, please kindly share and hit the subscription button. Tango, aluta continua.